Good morning. Today we are going to discuss two very important aspects of continuity. First is the algebra of continuity. That is we write algebra of continuous functions. The sum of two continuous functions is always continuous. The difference of two continuous functions is always continuous. The product of two continuous functions is continuous. The quotient of the two continuous functions is continuous. That is, we have if f and g are two continuous functions of x, then f plus g is continuous. Similarly, we have f minus g is continuous. Then we have some constant times f is continuous, where c is a constant. Then we have f into g is continuous and f upon g is continuous for all x such that gx is not equal to 0. Now, in order to do questions based on them, so we have question number 21, which says that discuss the continuity of the following functions. A part is fx equal to sin x plus cos x. B part is fx equal to sin x minus cos x, and C is fx equal to sin x into cos x. We know from our previous knowledge that sin x and cos x are two functions whose limit always exists and is equal to the value of these functions. So, we write since sin x and cos x are two continuous functions, all the functions in parts A, B and C are also continuous. Okay. Now, on the same way, same lines, we can do any question of this kind. Now, let's take up question number 19. Question number 19 says the function is defined by gx is equal to x minus minus greatest integer function of x. Now, clearly x is continuous, it being a polynomial. Now, gx, since it is difference of two functions, okay, it will be continuous provided both the functions are continuous. Out of these two, x is definitely continuous. So, to check the continuity of gx, we only need to check the continuity of the greatest integer function x, since x is always continuous. Okay, now to check the continuity of this, what will we do? first we will redefine this function. Okay, so we know that greatest integer function is always equal to n, where x belongs to n plus 1 and n is an integer. Okay, so we know that greatest integer function is always has an integral value. Okay, now to check for the, so if you want to find the value of x at n, suppose, okay, so at x equal to n, we have, or we want to check in the vicinity with respect to x equal to n. So what will you have on the value of the function would be n. If you want to check on the right hand side, the value would be, means for all x lying on the right of n, the value of greatest integer function would still be n. But if x lies on the left of n, the greatest integer function of x would be n minus 1. Okay, so we need to check the continuity, so we can divide it at the interval as x equal to n, x greater than n and x less than n. But here you will have to write n plus 1 and here it is n minus 1. So we will be dividing the entire number line into small intervals of integers basically. So now let's check the continuity at each of these points. Okay, now first we check, so we can also redefine the greatest integer function as it is equal to n minus 1 when x is less than n, it is equal to n when x is greater than or equal to n but x is less than n plus 1. So in this and here, but x is greater than or equal to n minus 1. So these are the small intervals into which we divide the greatest integer function. Okay, now so at x equal to n, the value of the function is greatest integer function of n, which is equal to, at x equal to n, it will be equal to n. Now left hand limit x tending to n minus fx is equal to limit x tending to n. You remove this minus sign, replace fx with definition on the left of n, which is n minus 1. It comes out to be n minus 1. Right hand limit x tending to n plus fx is equal to limit x tending to n. You drop the plus sign, replace f by function on the right, which is n, and the value comes out to be n. So clearly left hand limit is not equal to right hand limit, and therefore fx is not continuous at x equal to n. Whereas when x is less than n, the definition of the function is n minus 1, which is continuous being a constant function. When x is greater than n, fx is defined to be n, which is again continuous being a constant function. Thus greatest integer function fx equal to this is continuous for all all values of x except the integral values, means except for the integers it is continuous at all, and it implies that the given function gx equal to x minus this is also discontinuous wherever this greatest integer function is discontinuous. So, for all integral values of x, for all other values it will be continuous. Okay. Now, we deal with, similarly you can try question number 20 and 22.